Hello, algebra students. Mr. Lawrence here. In case you couldn't have guessed, yeah, you probably thought it was an air raid, but no, it's just Mr. Lawrence. Yes, we are here with our first real algebra video. Okay, we're going to start getting into this thing called the Common Core, and it's probably going to be a little different than what you're used to, but I'm going to do my best to make the transition as smooth as possible. All right, today we're talking about piecewise functions. Piecewise functions. And we're going to be looking at some graphs, and we're going to be checking out some situations. There's a couple things I have to deal with first. First of all, I want to shout out to Kiona. I was really proud of you. I think it was Wednesday in class, how much you were participating. Great job, sweetie. Keep up the good work. And I wanted to point out that that Taylor did some really hard work getting ready for that test. I hope she gets a good grade on it. You know, I'm rooting for you, Taylor. And let's not forget, hold on one second here. Let's not forget Dan. Dan is very happy to be in algebra. You can tell he has a big smile on his face, and he's working very hard. And of course, we can't forget Jarrett. Yes, Mr. Stevens, I know you sit back at the table now. To Kelsey, I've got your name down. Hopefully I won't call you anything else. All right, anyway, now that that is taken care of, let's go ahead and get on with this. Now, when we're doing piecewise functions, often it's going to be like a verse graphing situation. What does that mean? Well, it means kind of against, like distance versus time. Okay, now I know you're smart enough to know that, hey, the longer I drive, the more time I take, the farther I go, right? Okay. By the way, we call these two variables, one dependent and one independent. And the way you can tell, well, first of all, x is your independent variable, or it might be another letter, but typically it's x. Okay, and then y is your dependent variable. And the way you tell the difference, you have to ask which one depends on the other. Does the distance you go depend on the time, or does the time depend on the distance? Well, the distance depends on the time. The longer you drive, the further you go. So the distance depends on how long you've been driving. This is your dependent variable, okay, y, and your independent variable is the time. Because time's going to keep moving on and on and on. But the longer you're driving, the farther you're going to go. So the distance you travel is going to depend on how long you go. You know, if you drive for 1 hour, you're going to go 50 miles. You drive 2 hours, you're going to go 100 miles, assuming that you're going 50 miles an hour in that situation. Now, what about an earnings versus time? Well, the money you make at a job, does that depend on how long you work? Or does the time you work depend on the money you make? Well, that second one doesn't make sense, does it? Earnings depends on time. So again, time is your independent variable. It stands alone. Like the Declaration of Independence, we told England, hey, we don't want to be a part of you anymore. We want to be independent of you. And then the earnings, the longer you work, the more money you're going to make. And so that is your dependent variable. Now, we're going to look at a couple graphs here. Now, in class, you're going to be actually working backwards. You're going to be watching a real-life situation, and that real-life situation, you're going to make a function out of it, okay, a graph, a piecewise function. All right, talk about a family vacation, and this will be a distance versus time. And we're going to look at this chart here, this graph, okay? And before we actually do any math with it, we have to examine what's going on. We have to think about it. You know, these words have meanings. Well, first of all, we have our y-axis here, don't we? And that's the distance traveled in miles. So this is how far you've gone. By the way, this would be your y-axis, right? So this is your y-coordinate or your dependent variable. Now, along the x-axis, all right, we have our time in hours, okay? Time is the independent variable, and it's along the x-axis. That's not a coincidence. I put the independent variable along the x-axis and the dependent variable along the y. If you think about the simple graphs we did like this, where we made a table and we went x, and then we went 3x plus 1, and then we went y, and then we got an ordered pair, right? X, y. And we plugged a number in for x, didn't we? Because it's independent. X can be any number. Now when x is 0, we do the evaluation here of the expression, and we find that y is 1. See, y is only 1 because x was 0 to begin with. Now if x was -3, then, oops, got ahead of myself there, sorry. I'm going to have 3 times -3 plus 1. -9 plus 1 is going to be -8. In that case, y is -8 because it depends on what x is. Y is the dependent variable. Did I say that enough times? Y is the dependent variable. All right, so we don't need this for this particular problem, but I'm just trying to relate something we did recently to what we're doing now. Okay, now one thing I want you to notice, and this is very important because kids so often like to just rush through stuff. What do you notice? Let me get up. What do you notice? Your time here is 0, and what happens as you move right? Well, the time is increasing, of course, just like on a number line. So in other words, as this moves along, your time is going up. You've driven for 2 hours, now you've driven for 3, then you've driven for 6 hours, you've driven for 10 total hours, etc. Okay? Now, a similar idea over here on the vertical side. Okay, how far have you gone? Well, as you move up, the distance you've actually traveled is increasing, right? All the way up to 1,000 miles in this case. Okay, so let's take a look at this piecewise function and let's see if we can't figure out what's going on here. Well, the first thing I notice is that there's some different kinds of slopes here. And I'm going to highlight them. I see I've got this slope here, right? And I'm actually going to do them in different colors so they stand out a little bit better. And then I've got this part here. Okay. I've got this little stubby horizontal one there. And then we've got this one here. That overlap is unintended. It's just because the highlighter is so bulky. So we're just going to pretend the blue part is right there. And then I need one more color. Ooh, there's an ugly color. Ooh, it's actually too ugly. Yeah, let's go with that one. Okay, and that's going to go from here to here. So there's the pieces of the graph. Well, what information do we know? Well, let's see here. How much time has gone by? Well, 6 hours. See this first piece? I'm only talking about the yellow piece. In 6 hours, the family drove, let's see, I'm counting by 50s it looks like, right? 50, 100, 150. So the family has driven 350, looks like a little bit more. I'm going to say 360 miles. The first 6 hours, the family has driven 360 miles. Okay? Now the next 6 hours, the family drove from here to here, right? They only went up this distance. So they went an additional, it looks like, if I'm counting by 50s, it looks like it's about 100 miles. Now there's going to be some variations in answers when you look at charts because they may not hit an intersection perfectly. Okay, now something strange is happening here. It seems from the 12th to the 13th hour, 1 hour, they went 0 miles. I wonder why that could be. We'll talk about that more in a minute. All right. And then from the 13th to the 17th hours, 17th hour, oops, that would be 4 more hours, excuse me, 4 more hours. The family drove from here, let's see, 100, 200, 300, About 400 miles. And finally, they went the last 3 hours. They went a distance of, let's see here. Let's go from here. Let's go. I'm going to say about 140 miles. 140 miles. Okay, that's this distance here. Okay, from there to there is about 140 miles. Now, I'm going to break this up into some time intervals. Let's suppose the family started their trip at 9 p.m. They decided to drive through the night. It was a long night. Okay, and so I'm going to say, let's say from 0 to 6 hours, the family has gone 360 miles. Okay, from 6 to 12 hours, they've covered 100 miles. Ooh, they must have slowed way down, huh? Yeah, because in 6 hours they went 360, but the next 6 hours they only went 100 hours. Man, I don't want to be driving that car with some kids in the car. I'd be going crazy. Only 100 miles in 6 hours? Might as well get out and walk. Okay, now look at this. See the yellow segment? Right? It's steeper than the green segment, isn't it? Yeah, that's because they're driving faster. It's going up higher. The y value, or the distance, is increasing at a faster rate as the time moves to the right. On this one, it's moving up a smaller amount as the time moves, and therefore it's they're not going as fast. Now, from the 12th to the 13th hour, the 12th to the 13th hour, they haven't gone anywhere. 13th hour. They've gone 0 miles. Right? See, it didn't move up at all as it moved to the right. Now, from the 13th to the 17th hour, so from the 13th to the 17th hour, they went 400 miles. And from the 17th to 20th, they went 140 miles. So 17th hour driving to 20th hour driving, they went 140 miles. And the father's probably going crazy. 20 hours in the car. Kids are going stir crazy, bouncing off the walls, had too much sugar. Oh no. All right, so that's what this graph is trying to tell us. Now, on this graph, we can figure out a lot of things. You know, we said that yellow segment looks like they were driving faster than on the green segment. Well, do you think it's at the fastest speed? Or is there a segment that looks steeper? I'm thinking this purplish one looks even steeper than the yellow one. Okay, now the pinkish one, or peach, or whatever color that is there, I'm not sure. It might be, but it looks kind of close. Well, we can figure out their average speeds. We use a very famous equation. You'll see it in science this year. It is called distance equals rate, or speed, divide rate times time. Rate times time. Okay? Now, this is just an equation. D is for distance, R is rate or speed, and T is time. And if we know any parts of it, two of the three variables that is, we can figure out the average rate. So let's try to figure out the average rate for the yellow segment. Let's see how fast the father was driving, or the mom, if it was a mom driving. Hopefully it wasn't one of you guys, because you don't have a driver's license yet. All right. In this first part, the yellow part, the family drove 360 miles. How long did it take them? It took them 6 hours. Now we don't know we don't know how fast they were going. So notice I just plugged in 360 for D. I plugged in 6 for T, my time, and now I have R. Well, I'm going to solve this one-step equation for R. What's keeping R from being alone? The 6. Okay? And when I do that, the 6's will cancel. I'm left with R equal to 60 miles per hour. So that means for this yellow segment, the person driving, again, it's hopefully not one of you, is driving 60 miles per hour. Hey, by the way, let me draw attention to something really important here. Oops, I didn't mean to erase that part. Per hour. Okay, you just saw me go 360 equals R times 6. And I divided by 6 on both sides, right? What's 60? It's a distance. What's our distance in this one? It's miles. And what's the 6? Well, it's hours. It's our time. It's our hours. Do you know how to read this? Miles per hour. That's why it's miles per hour, because you're dividing miles by hours. Didn't I do that? Didn't I take 360 miles and divide by 6 hours? So that's why it's miles per hour. It's just not made up. It means a division is occurring. The distance you travel divided by the time you go. That gives you how fast you're going. So when you look at mom or dad's speedometer as they're driving along the road, if it says 45 miles per hour, there's a distance being covered by the car, a time it's taking to cover that distance, and when you divide them, you get the number 45. Yeah. Okay, so let's come back up here and see if we can't figure out the rate for the green segment. Okay, and the rate for the green segment, how many miles did they go? They only went 100 miles this time, and it still took 6 hours. So I'm going to divide 100 by 6, and that's not going to come out evenly. And so when I divide by 100 by 6, I'm going to get 16.6 repeating, which is really more like 2/3 miles per hour. Now, why would they be going so slow? Well, let's think of some reasons. First, they're zipping along at 60 miles per hour, and now they're down to 16 2/3 miles per hour, or 16.6 repeating. Well, it could be that the car has having some engine trouble. It's not working properly, and so they can't go very fast. It could be that there's a traffic jam, and people are slowing way down, right? Let me think of, I think those are some pretty good reasons, okay? Now, that's an average speed. It doesn't mean the car is actually going 16 2/3 miles per hour at any given moment in the car in that green segment. It means that's the average speed during that time. All right, now let's go to this purple section. Well, it sure looks faster to me there, but let's test it and see if it is. All right, in the purple section, how many hours did they drive for? Oh, I skipped the blue section. I'm sorry. The blue section, well, how fast are they going? They're going 0 miles per hour, right? 0 miles per hour? 0 miles per hour. Well, how could that be? Well, maybe they stopped for lunch or breakfast or something. A whole hour, they didn't move at all. They could be stuck in traffic. There could be an accident in front of them. But for whatever reason, they're not traveling at all. They're stuck. Maybe they're eating. Okay, now let's go to the purple section. And in the purple section, we have that they went 400 miles in 4 hours. Well, 400 miles in 4 hours, dividing by 4, the rate is going to be 100 miles per hour. Uh-oh, I hope there's not speeding. I hope they're in Montana or on the Autobahn or something where you're allowed to go that fast, because mom or dad is going to get a ticket. They're flying, and look, that purple section is steeper than the yellow section. All right, finally, let's go to this pink section. And let's see, there we go, that'll work. In that section, they go 140 miles in 3 hours. Notice all I'm doing is plugging in the distance and the time into the equation, d equals rt. And I'm solving for r in every case. 140 divided by 3, it's going to be faster, but not as fast. It comes out to be 46 2/3 miles per hour. So you see, this piecewise function told us a lot. And we can look at each piece and analyze what's happening in the real world. That's what's cool about algebra. Things are starting to make sense in the real world if we let them. All right, there's another graph I want to look at. Oops, where is my mouse? Can't seem to find it. All right, there we go. This is money earned by an hourly employee. You get a job, you make so much per hour. Now, somebody who's salaried, like a teacher or work for a company, an engineer, we don't make it hourly. Like if I do extra work on the weekends, I don't get extra money. I get a set amount of money per year. But when you get your first job, you probably won't be salaried. The person will agree to pay you. Let's see if we can figure out how much money this person is making. I've got a 19 in there kind of randomly. I don't know why. I'm going to take him out. Okay, let's look at our graph first of all. Here along the bottom, our hours spent working, there's our independent variable again. There's our X. Okay, and our money earned in dollars is Y, so it means they, here they made $19, here they made $38, $57, $76. Let's take a look at this graph. I really like the highlighting thing I did before, so I'm going to do that again. I'm going to highlight the sections. Okay, and so there's that one. And I've got this one here. And then finally this purplish one. Okay, now let's see what went on here. It looks like somebody went to work for 4 hours. You see the 4 hours? And during those 4 hours, first 4 hours, they made $38, right? But then there were 2 more hours at work. So the next 2 hours, how much money did they make? Well, they didn't make $38 because they were at 38 to start with. It doesn't go up. So they made $0. See, they made no money during this time. And then they worked another 4 hours, and they made from 38 to 76, excuse me, it's been a long day, another $38. What do you think is happening here? This green section. Because they worked for 4 hours. They're still at work, but they're not getting paid. I wonder, hey, maybe they're on a break. When I used to work at the Olive Garden, sometimes I would work a double shift. And I would work lunch from, say, 10 to 2. They would close my section for 2 hours. And then I would work from 4 until they could close my section again. If it was a slow night, maybe they closed it at 8. If it was a busy night, maybe they'd close it at 10:30. Okay? So, let's see how much money they're making per hour in each section. All right, this yellow one. Okay, now, by the way, this is very similar to distance equals rate times time. It's similar. I'm going to take the money earned, and that's going to be equal to the hours that they work times their pay rate. Okay, so I'm taking the total, the money earned, that's going to be equal to the number of hours times the rate. So if you make $3 an hour babysitting, then you work 5 hours, 3 times 5 is 15. So you'd have $15, right? Okay, well, let's check it out. This first section, the money earned is $38, and the hours they worked are 4. We don't know their pay rate. It's a one-step equation. I'm going to divide by 4, and I think half of 38 is 19, half of that is 9.5. This person is making $9.50 an hour. You can verify that. Divide 38 by 4 and you should get 9.50. So for this stretch here, they're making $9.50, but that's per hour. And over here, we divided money by hours, didn't we? 38 was the money, 4 was the hours. So the rate, in other words, is the money divided by the hours that you work. Okay, now in this green section, they didn't make any money. That means the dollar sign, the money made, is 0. Okay, now they worked for 2 hours and we want to know their pay rate. Well, this should be real simple. Okay, now some of you get really confused on 0 divided by 2. I don't know why it would be confusing in this particular problem because you didn't make any money over those 2 hours. So what was your pay rate? 0. $0 per hour. The company's not going to pay you to take a break. I mean, I guess you could have that negotiated contract, but if you're an hourly employee, they won't pay you for your break. All right, so $0 per hour right here. Oops. Okay, $0 per hour. All right, finally, this last section, it's going to end up being the same. I know this because if you look, the lines are exactly the same. They're in different locations, but they're the same. So, if he's going to make $9.50 per hour. Now, if you didn't believe me, you could figure out how many hours he worked. Oh, 4, 6 to 10 is 4. And then how much money he made. Well, it'd be 38. And again, you get $38 divided by 4 hours. And that would be your answer. Okay, we're going to get some practice with this tomorrow in class. You're going to watch a video in class and you're going to talk in some groups and try to see if you can make some sense out of this. All right, Mr. Lawrence signing off. Have a good night, everybody. Where's my mouse? I can't stop the video. Ah!